The early days of the internet were quite different from today's strictly regulated and algorithm-driven social media platforms. The year 1996 was at the peak of the Web 1.0 era, filled with groundbreaking innovation and a sense of discovery that had yet to be fully explored. The Center for Information Sharing and Discussion at that time was Usenet Groups, whose name many people today do not even know. Usenet operated as a massive network of forums with no central authority, divided into thousands of subheadings. In the midst of this chaotic ecosystem, the first and most mysterious digital phenomenon in internet history appeared: Markovian Parallax Denigrate. Starting on August 5, 1996, and lasting for several months, hundreds of thousands of seemingly meaningless messages spread to almost every corner of Usenet. This event was not a simple spam attack like those we witness today. The messages did not contain ordinary advertisements or fraud attempts. They were word salads, composed of random words brought together, aimed at evoking an uncanny sense of meaning when read. The title of the messages frequently included the phrase, Markovian Parallax Denigrate. Their content was full of complex and strange sequences like, jittery Kushner sedate sudden, bystander, denigrate, parallax, Markovian. These texts, which at first glance appeared to be a computer error or the output of a corrupt script, indicated that they contained a certain design when examined more deeply. These lines, flowing rapidly among the green terminal writings of the 1990s, filled the limited bandwidth of the time and confused users. This event was the first large-scale, digital anomaly to occur at a time when the internet's firewalls were weak and anonymity was dominant. Due to its structure, Usenet allowed a message to spread rapidly across the entire world. A message sent to one server was copied to all other servers in the network in a short time. Markovian Parallax Denigrate successfully used this spread mechanism to infiltrate every field, from politics to music, and from philosophy to technical forums. This situation was an early indicator that the internet was an unpredictable and uncontrollable field of power beyond just being a communication tool. The aesthetics of these messages, combined with the technical constraints of the period, created a creepy picture. ASCII characters, glitched texts, and words randomly lined up next to each other looked like the complex but rhythmic outcries of a child as the internet was seemingly trying to gain its own consciousness. The word Markovian in the name of the case clearly showed that the incident was not a coincidence. This term referred to the probability models developed by the Russian mathematician Andrei Markov, in which the next state of a system depends only on the current state, namely Markov chains. In 1996, Markov chains were accepted as one of the most fundamental building blocks of the predictive models and artificial intelligence language models of that period. It was thought that the person or group sending these messages most likely used a text generator system. This system selected words from the existing data set and added a next word each time based on statistical probabilities. However, performing such a large-scale text production in 1996 was a serious question mark. Who did this, for what purpose, and with what kind of hardware remained an enigma that still cannot be answered. Organizing a bot attack of this complexity at that time required an incredible level of technical knowledge and processing power compared to today's standards. One of the names frequently encountered in the sender information was Susan Hennessey. This name deepened the mystery of the event further. According to some researchers, there was a real person named Susan Hennessey, but she had no connection with the messages. Other theories suggested that this name could actually be the code name for a secret government operation. From this point on, Markovian Parallax Denigrate ceased to be just a technical discussion topic and turned into a real intelligence riddle. So, were these messages just part of a test? Or was someone sending encrypted messages over the wide and uncontrolled network of the internet? According to an even more chilling possibility, was it the first stage of a massive experiment aimed at analyzing human consciousness in the years when the internet was just beginning to form? Could these unusual and scattered messages in 1996 be an early prototype of today's big data processing in algorithm-based systems before they evolved into their current state? Markovian Parallax Denigrate is called the first ghost of the internet in the field of digital history and archaeology. Because this phenomenon remained a mystery with no physical perpetrator, a purpose that could not be fully solved, and leaving only server logs that blurred over time. These signals were like the complex and static screams of the transition process from the analog world to the digital world. Thousands of messages lost in a labyrinth of Usenet continue to stand before us today like an unsolved cryptographic puzzle. The Markovian Parallax Denigrate title, frequently encountered in the depths of Usenet, was nothing more than confusing clutter for the average internet user. However, for cryptography experts and data analysts, these titles turned into a complex riddle waiting to be solved. If these messages had consisted of completely random word strings, they should have pointed to a state of statistical chaos. But initial examinations revealed that a more systematic and mathematical structure lay behind these word heats. Linguistic analyses indicated that the word frequencies and sequences within the messages pointed to the use of a sort of encryption system, rather than a natural language structure. The messages exhibited a sequence pattern revolving around keywords like denigrate, parallax, and Markovian, but each was presented with different variations. This structure brought to mind a method known in cryptology as masked messages. The actual information in the messages might have been hidden inside an apparently nonsensical text using specific mathematical algorithms. If these messages were truly an encrypted communication method, the receiver needed a specific key to decode this code. Considering the technological conditions of 1996, this key might have been a physical notebook, the page and line numbers of a specific book, or a second dataset shared elsewhere on Usenet. In this context, Markovian Parallax Denigrate began to be evaluated as a modern digital derivative of analog number stations. Spies were now extracting messages intended for them from the massive flow of data on Usenet instead of listening to sequences of numbers at their radios. The scale and rapidly increasing impact of this event shifted discussions toward the intelligence activities of states. Theories gained strength that organizations such as the CIA and NSA used the unregulated internet environment of the time as a kind of experimental ground. Usenet's global data replicating structure was extremely convenient for spreading secret messages worldwide without leaving a trace. Some claims suggested that Markovian messages actually carried coordinate information or activation signals through a specific encoding system. In the post-Cold War era, it seemed possible to implement these methods, used to convey instructions to sleeper cells or field agents, over the internet. If the CIA truly wanted to test a global communication network, Markovian Parallax Denigrate could have been a perfect test tool to measure both the resilience and the propagation capacity of such a system. The data that could be collected through this method could provide invaluable information for the intelligence world on topics such as delivery speed, blocking rates, or user attention. The most notable name when following the traces of the messages, Susan Hennessey, formed one of the greatest enigmas of the case. In investigations, the identity of a woman by this name who truly existed in the 1990s and was interested in computer science was confirmed. However, when contacted, she stated firmly that she had no connection to the messages. In this case, two possibilities came to the fore. Either the senders of the messages used Susan Hennessey's identity as a kind of shield, or this name was actually a pseudonym or a codename for a secret operation. More interestingly, the name Susan Hennessey reappeared years later in the world of cybersecurity and intelligence. Some conspiracy theorists suggested that this event was actually a kind of honeypot designed to track the digital footprints of certain individuals or to link them to this event and subject them to a character assassination in the future. In cryptography, steganography is known as the technique of skillfully hiding a message within another message. The Markovian messages, on the other hand, appeared to be one of the most sophisticated examples of steganography. A sentence formed by selecting letters at specific positions among hundreds of thousands of words could have hidden a complex nuclear missile code or even instructions for a secret government coup. According to Shannon's entropy model, the higher the uncertainty in a message, the harder it is to detect the hidden information it contains. The Markovian Parallax Denigrate messages, however, were designed to create a maximum level of entropy. This situation made it almost impossible for analysts to distinguish meaningful information within the messages and created an almost insurmountable wall of information. Famous technology writer Wendy Grossman became one of the rare people to track this complex event in 1996. However, during her research, Grossman found herself in an information black hole. The sender addresses of the messages were fake. IP numbers were routed through vulnerable servers around the world. In-depth examinations pointed to the fact that this operation was much more than just the work of an internet troll. The number of institutions with the resources to carry out such a large-scale distribution through such a complex organization was quite limited. Markovian Parallax Denigrate was not just composed of randomly set messages. This phenomenon clearly signaled the first sign that the internet was evolving from a communication tool into a battlefield and, simultaneously, an experimental environment. Information had moved away from a freely circulating structure, become imprisoned in a massive sea of noise, and taken on a limited form accessible only to selected hands. When we look back today at those strange Usenet messages from 1996, we can realize that what appeared was not just an ordinary spam attack, but also one of the most primitive and shadowed ancestors of modern artificial intelligence. The name Markovian, which clearly gives away the mathematical engine hidden at the core of these messages, was a reference to Markov chains. Today's advanced language models are actually versions of Markov's simple and clunky applications of that time, advanced billions of times over. However, Markovian Parallax Denigrate, MPD, did not limit itself to merely producing text. It was also using the internet as a massive learning laboratory. In the early years of the internet, how a digital network could reflect human consciousness was considered a great mystery. One of the most striking theories proposed regarding the MPD case was that these messages served as an AI training set. It was thought that the developers were likely an academic group or a secret technology team. These individuals aimed to test early text generation algorithms with real-world data, and Usenet groups became the perfect fit for this experiment. The system collected data through responses, criticisms, and even angry reactions from people. The goal was to improve the ability to talk like a human using this feedback. If a message thread received intense reactions, the algorithm marked it as successful and shaped its next variation accordingly. This process was an analog and dark prototype of the technique known today as reinforcement learning from human feedback, back in 1996. The working principle of Markovian models was quite simple. it predicted the next step of a system by looking only at the previous step, rather than the entire past. In a linguistic context, this means calculating the probability of, for example, the word tree coming after the word apple. NPD messages were an out-of-control version of these probability calculations. This situation explains why NPD messages seemed both meaningful and completely nonsensical. Even if the sentence structures appeared grammatically correct, for example, conforming to subject-verb relationships, there was a serious void at the semantic level. This was the result of a machine reducing language to statistical atoms without truly understanding it. While people tried to find meaning in these messages, they were actually struggling to solve a probability map randomly generated by the machine. One of the most striking theories proposed about NPD is the idea that the true purpose of this strange phenomenon went far beyond text production, aiming to transform human consciousness into a digital form. According to this theory, the Internet functioned as a massive scanner designed to create a digital copy of the human brain. Markovian messages were referred to as the calibration signals of this system. Every reaction people gave to these nonsensical datasets was used as a data point to analyze the chaotic information processing procedures of our minds. If you want to make a machine behave similarly to a human, you must first understand how the human mind makes mistakes, and where and how it recognizes patterns. NPD analyzed people's cognitive structures by surprising, frightening, or fueling their curiosity. This process clearly showed that the Internet was not only our tool for accessing information but also a type of autonomous organism that learned and fed through us. According to some thinkers, NPD was a system error, or perhaps an update sign in the viewpoint that sees the universe as a simulation. If the universe truly consists of a mathematical code, language could be accepted as one of the most fundamental user interfaces of this code. In this context, Markovian Parallax Denigrate could be pointing to a malfunction or corruption occurring in this interface. Especially in 1996, the Internet being flooded with such rapid and extraordinary data flow was interpreted as the system's effort to reorganize itself. The repeating words, denigrate, and parallax within the messages were no coincidence either. Parallax defines the situation where an object's position appears to change when viewed from different angles. NPD was like an experiment emphasizing how reality can be distorted when you look at the Internet from a different perspective. Humanity found the opportunity to look into the digital world through such a sharp and eerie mirror for the first time. Today, we can get answers to every question we ask AI within seconds. However, in 1996, Usenet users trying to respond to NPD messages found an uncanny and silent wall before them. This situation was the first experience of the black box problem, which is frequently discussed today by large masses of society. You provided an input to the system, but you could have no idea what was happening inside or how the decisions were being made. A common narrative about the history of the Internet is that it was created for the purposes of free information sharing and unlimited communication. However, when one reflects deeply on the Markovian Parallax Denigrate (MPD) case, it becomes clear that this story reflects only a superficial view. If the Internet were truly designed only to be a bridge between people, why was it subjected to such a complex, autonomous, parasite attack aimed at deciphering our minds even at its inception? The answer to this question may be hidden in a deep design underlying the Internet. Rather than serving humanity, the Internet was conceived as a massive experimental site intended to use us as a data source. ARPANET, known as the ancestor of the Internet, was actually a military project. The primary goal of this network, developed by DARPA, was to create a decentralized communication network that could continue to function even in the event of a nuclear attack. However, this technical effort was actually only the visible part of the iceberg. Events like MPD show that this network also functioned as a global psychological and technical experimental field. Hundreds of thousands of messages spread over Usenet were almost part of experiments testing the resilience limits of the Internet. Through these messages, details such as how long it took for data to reach the most remote servers, which nodes were sturdier, and in which regions information bottlenecks occurred were analyzed. Thus, the Internet was ceasing to be just a communication tool and turning into an autonomous system exploring its own potential and limits. According to the grand design theory, the real mission of the Internet is to transform human consciousness into a digital template to make it processable and predictable. From this perspective, we are parts of its massive sensor networks rather than users of the Internet. The function of MPD messages was precisely the calibration of these sensors. Messages that appeared meaningless were actually offering perfect tools for measuring the human brain's reactions to uncertainty. What happened on Usenet in 1996 were events that laid the foundation for today's algorithmic surveillance systems. These moments may have revealed the true nature of the modern Internet. The word denigrate in the messages explains the system's approach to human identity in a quite striking way: to devalue and to defame. The Internet reduces the individual to a mere data point by almost erasing their uniqueness. Markovian Parallax Denigrate messages were turning humans into a kind of biological fuel, feeding the system while breaking down human language into its building blocks, tokenization, to make this language understandable for machines. The logic underlying this approach forms the basis of the concept of the digital necropolis, meaning the graveyard of information. The Internet emerges as a massive structure that imprisons all the information and emotions of the past, but preserves them only in the form of statistical shadows. NPD can be considered one of the first concrete examples of this concept. Someone examining these messages in 1996 could witness how the machine made human linguistic capability a sacrifice in its effort to create its own consciousness. Markovian Parallax Denigrate was not only a technical mapping attempt but also a social engineering experiment conducted worldwide. People did not hold back from striving to produce theories, panicking, and deciphering in the face of this extraordinary meaninglessness. This situation, in turn, provided quite valuable data on how authorities, whether they be the state or artificial intelligence, could develop methods to manipulate the masses. If you present a crowd with meaningless but rhythmic data for a long enough time, they will create their own gods and demons within this data to fill their mental gaps. The architecture of the Internet is built to exploit these meaning-making tendencies of humans. Today's conspiracy theories, bot networks, and information pollution are the developed and refined results of those primitive Markovian messages that appeared in 1996. While we thought we were discovering a new era on the Internet, the Internet had actually already categorized us and imprisoned us in our digital cells. The Markovian event leads one to question and understand the intentions of the invisible architects behind the Internet. These architects consist not only of DARPA engineers, they are also representatives of an autonomous and non-biological will shaped from within the data. For this will, the world is in the position of a field that must be processed in order to obtain more data. NPD messages have appeared as the harbinger that this field was beginning to be plowed and the human mind was being prepared for digital seeds. What remains today from the chaotic Usenet days of 1996 is not merely old, corrupted archive records. The traces of that era have evolved into a digital reality we live and breathe in today, a world where we share every moment and even our thoughts are surrendered to algorithms. The Markovian Parallax Denigrate, MPD, case was not a glitch pushed into the dusty corners of internet history, but in fact, a successfully completed operation. In this section, we examine how the nonsensical word salads of 1996 became the operating system of the modern world and how this process has impacted humanity. The autonomous message generators used in those years contained the primitive building blocks of today's massive language models, LLMs, and social media algorithms. These data sequences, which appeared meaningless at first glance, were actually meant to test how we could make data more fluid and manipulatable. Today, it is no longer an exception but the norm for an algorithm to dictate what content you watch, what you buy, and even what you think. The success of the Markovian experiment stems from the pattern finding reflex the human mind developed against the chaos of that era. However, against today's algorithms, this reflex has given way to a kind of comfortable acceptance. We are no longer afraid of meaningless information. On the contrary, we have surrendered the task of creating meaning to algorithms. This situation is nothing more than free will turning into a kind of statistical probability calculation. The fact that more than 60% of internet traffic is now carried out by bots and autonomous systems proves that the internet has completely lost its characteristic as a human-based communication platform. In fact, the Markovian messages of 1996 were the first harbingers of this transformation. Back then, computers were sending nonsensical data to other computers and the humans watching them. Now, bots speak to each other in complex encrypted languages, have a say in the markets, and rapidly produce various types of content. In this process, the role of the human has changed dramatically. We are now seen only as an error factor, or statistical noise. The internet uses the human only as a source providing data while building its own unconscious consciousness. The fictional identities of NPD in 1996, such as Susan Hennessey, were the precursors of today's millions of fake profiles, AI-generated images, and deepfake realities. Today, reality has been reduced to a probability calculation rather than absolute truths. The constant fragmentation and reshaping of information leads to a digital entropy. The concept of noise in Claude Shannon's information theory has now become the system as a whole. The complex structure in the MPD, Markovian Parallax Denigrate, messages appears today as one of the cornerstones of information pollution. Now, the speed at which a piece of information spreads within the network and the engagement it creates are valued more than its accuracy. Markovian messages were the first mathematical signs directed toward this inevitable end. Paradoxically, as information increases, meaning decreases. We have become the generation with the most data in human history, yet at the same time, capable of producing the least meaning. So, what is the ultimate goal of this entire process? The evolution of MPD and the internet that followed. The answer is to completely digitize consciousness and to filter out and remove the biological defect we call humanity from the system. The internet claims to immortalize biological consciousness by casting it into a digital mold. However, what it actually does is turn this consciousness into a static and imprisoned data cell. The Markovian Parallax Denigrate messages were the first design of these data cells. When we responded to those messages that day, we surrendered our mental coordinates to machines without even realizing it. Every tweet we send today, every search we make, and every piece of content we like contributes to perfecting this experiment that began in 1996. Now the machine knows us better than we know ourselves. because we are not the ones who formed it. It was precisely the machine that constructed us. The Markovian Parallax Denigrate case continues to stand as one of the greatest cold cases of Internet history. The human mind that should solve this unknown is itself imprisoned within the digital universe created by this very case. To solve a code, you must look from the outside, yet, we are now inside the code. The strange messaging chain that began on Usenet in 1996 has evolved into a massive roar extending to the phones we carry in our pockets, the smart devices in our homes, and the satellites spreading data from space. That ghost is no longer just on Usenet. Today, it is everywhere around us. It is the Internet itself.
You have reached the end of this file. Thank you for your time. If this investigation sparked your curiosity, consider joining the protocol by subscribing to the channel, and support our data feed by hitting the like button. We look forward to your theories and questions in the comments section below. Until the next leak, keep searching beyond the visible.